Okay, so today I'm gonna show you the functioning of my patch of a Windmachine built in Pure Data. Okay, so the patch starts with the time list object that is able to read a list of values that represent the 24 hours of the day. So we have 24 lines of object with 3 values each. These 3 values are going to represent the wind direction, the wind average, and the wind maximum. These 3 values are then sequenced over 48 steps. There is a macro object that regulates the time in which these steps are gonna change. So we're gonna have a new step every 20 seconds. So if we look now at the signal based part of the patch, we can open the wind abstraction. Here we have on the left side a noise object that is filtered with a bandpass filter. Frequency is 800 and the Q value is 1. This noise is then going to be modulated by a random gust control, which is made of another white noise object that is heavily filtered with 2 low pass filters to allow a much steeper curve. Then is scaled by 5 and 0.2 is added to not allow the signal to go below 0. So on the right side we scale the signal even more in order to make it stay inside of a range. This way, when the wind speed is gonna be lower, the gust value are gonna be lower as well. So at all times the signal is in a normalized range. Then both signals are added together and the wind average data is going to control their amplitude. You can see the result on the wind table on the right. Now if we move to the whistling control abstraction, we see similar built from the previous wind abstraction, but instead this time we have an oscillator. We use the Windmax data in order to control the speed of the oscillator, so that is going to control how fast the whistles are gonna be. Then the oscillator is connected to a wind gust control as we did for the wind patch. Then is sent to the clip control in order to keep a range between 0 and 1, and its final amplitude is controlled by the wind average. So this way, when the wind gets lower, the whistles are gonna be lower as well. This control signal that we generated is then gonna be sent to 2 different noise objects that are triggered at different times with the delay read object. The first noise object is gonna be in a range between 600 and 1 kHz, while the second one is gonna be much higher in its timbre. Both the wind and the whistling control are then sent to the stereo L and R that go inside the equal pan abstraction and to the DAC. Both the wind and the whistling control are later connected to an ADSR envelope generator that controls the time in which they're going to fade in when the patch is initialized or fade out when we manually press the envelope 0 message that we have on the top. If we want to hear the sound located correctly, so how it really was at that time, and we have surround system made of 4 speakers, we can use the Granby pan object, which is an external library, to rotate sound with the data coming from the weather forecasts. So thanks for watching, and I hope you enjoyed this video.